This is Honors Physics. This is the final question from Chapter 2, or Electricity Homework Number 2, Chapter 19, Number 3. We have the positive terminal of an X-ray tube at a potential voltage of plus 125,000 volts with respect to the cathode, which is the negative terminal. We're looking for how much work in joules is done. Well, again, we can see that work is equal to our change in potential energy, electric, which is our energy at the anode, where it ends up, minus the energy at the cathode. So as we do that, that means that we are looking at our voltage at the anode times our charge, minus the voltage at the cathode times our charge. Because the difference between them is 125,000, we can write this as just negative 1.6 times 10 to the negative 19th, and multiply that by our potential difference, 125,000. So we end up with the work done being equal to negative 2.4 times 10 to the negative 14th joules. Now it's negative because we are allowing the electron to do what it typically will do, and that's go from a higher potential to from a lower potential to a higher potential, because we're going from essentially 0 to 125,000 positive. If we're looking in part B for the kinetic energy it has at the end, we should remember that the electron is going to speed up. So we see that our change in kinetic energy is equal to the negative change in potential energy, and that's electric potential, because the electric force is a conservative force. So that means our final kinetic energy, change in kinetic is kinetic energy final minus kinetic energy initial, but that's just 0. So we're left with a final potential energy of 2.4 times 10 to the negative 14th joules. And just to put that into perspective a little bit, if you use our kinetic energy equation, 1/2 mv squared, this ends up with a final velocity of this electron of 2.4 times 10 to the 8th meters per second, which is quite fast. It is, within 0.4 times 10 to the 8th meters per second of the speed of light, right? So it's upwards of 70% of the speed of light, and that is enough to release an X-ray as it goes so fast there, and then slows down as it slams into the anode. This is Honors Physics Podcast, question 3 from homework number 2.